Good evening, everyone. Welcome to this Matlab Masterclass series. Today is day 17. I warmly welcome you to the session. Thanks for coming and thank you for your time. I would also like to thank the Andhra Pradesh State Skill Development Corporation for their support for this program. So today's topic is augmented reality using Matlab. Okay. So before we go to the topic, let's start the day with a quote. So the quote is model the successful people. Okay. This is the quote which I would like to share you today. So check for the successful people in the field like which you are interested, okay, and see like what they do and how they become successful, and just model that, okay, so that you could achieve the same results. Okay, so this quote was from Tony Robbins, like model the successful people. I would just like to share with you. With this we'll start the day. So today's topic is augmented reality using Matlab. So today's topic we are going to cover up what is augmented reality and how it works and how to write the Matlab code for augmented reality, and what are all the applications of augmented reality. So these are the things which we will be covering up today. Okay, so stay connected till the end of the session, and I'll give a short introduction about Pantech and about me and like the announcement link, and we could start the session. Okay, Pantech was started in the year 2004. Like we basically manufacture embedded motherboards, DSP boards, and FPGA boards. We also have trainer kits for electrical and electronics lab equipments. We do manufacture renewable energy trainer kits, fuel cell trainer kits, and solar trainer kits. So if you want to know more about our products and services, just log on to our website pantechsolutions.net. So our vision is to help 10 million students to learn the technology in an easy way. So far we have caught up 1 lakh plus students on YouTube. So this year we have a mark of around 10 lakh plus students to train the students on the latest technology. So my name is MK Jeevarajan. Coming to the announcement, the link will be available at 9 p.m. and it will be valid for 2 more hours. Like you could fill the attendance form even after the session. Okay. So for internship candidates, no need to fill the attendance form, and you just give complete and continue on the LMS portal. Okay. All you have to do is after watching the video, just give complete and continue on the LMS portal, and please sign up for the Q&A session this week on Saturday at 10 a.m. Okay. So for some sessions we'll be using the recorded video sessions. This is a recorded video session. Like I will take the Q&A session tomorrow. We have also started the batch 2 internship for like the price is 750 rupees, and like the next batch will be for 999 rupees. Okay. So if you want to enroll for batch 2 internship, so you could enroll at 750 rupees now with inclusive of GST, and you will be having the video access for 90 days, and you could download the presentations and the source codes, and you could make use of them. Okay. So coming to the disclaimer, like Pantech is not associated with MathWorks, and we don't have any formal MOU with them. Like if you want to download the trial version, we have provided the link in the description box. You just sign up for the trial version for deep learning toolbox, which will cover up majority of the sessions. Okay. So let's go to the topic. Today's topic is augmented reality using Matlab. Okay, this is a fast growing field. Like it's the latest topic in image processing and one of the fast growing field in image processing. So what is augmented reality? Augmented reality is like this combination of the real environment and the virtual environment is called augmented reality. So the real environment is augmented by the virtual environment. So that's called an augmented reality. So in this case, you have a real environment video and you have a virtual environment, and the virtual environment has been superimposed on the real environment. So that's augmented reality. So the use cases, like the applications is large. Like I have covered up only 4 applications. You can go to Google and you could search for a lot of applications over there. So one application is on manufacturing, where you could show the AR app, like if you take a camera or a tablet and if you focus on an object, it will tell you it will give you the features of the object. And another thing is you could use it for fashion and retail, like it's where you will have an AR camera and a display device, so that no need to go for a trial. Like you could trial by choosing the dress as well as the glass specs and everything. So that's an example. Lenskart is an example for augmented reality, where you could choose the lens for the real-time camera, which is taken from the from your laptop, and the lens model can be fixed on your face. So that's an example for augmented reality.
A Google Map is also an example. Like if you show like a Google Map over the Google is building AR app for, like if you show the if you capture the frame from the camera on the mobile, like it will tell you like where the coffee shop is, where is the restaurant, and everything. It will map you based on the object, like based on the structure of the building as well as the logo recognition kind of thing. So that's an example for augmented reality. And for marketing, you could use it for augmented reality. So it will display the coupons, like coupons or discounts. So augmented reality can be used for marketing. So these are the some simple applications. So a lot of application is there. You could go for Google and you could search. And how it works, like it is based on object recognition and tracking. First thing is you have to do is the object detection and tracking. Then once the object is detected and tracked, then you could go for the replacement. Okay, replacement of the virtual environment. So first I will explain you like how an object recognition tracking works. We have covered up this session earlier. Like first thing is to prepare the target image as well as the real-time camera. You read the snapshot from the camera and you get the target image, and you map the features. You map the features, the serve features, and you recognize based on the features. The features, like you may map the corner features, the region features, or the blob features. In the previous case, in object detection, we have used serve features to map the features of the target image as well as the reference, the real-time image, the image which was captured from the camera. We map the features and we find out the object. So like that, if you have to map the features and you have to recognize and display. Finally, it has to be tracked for each and every frame. Each and every frame it has to be tracked, and you could get the tracking video. Okay. So once the object is tracked, once the object is detected and tracked, then you have the video to be embedded in the real-time environment, the virtual video which has to be embedded in the real-time environment. In this example, the above frame, this video frame is the virtual video which has to be embedded on this webcam frame. Okay, and this Matlab logo is the target image. This is the target image. So the first thing what you have to do is you have to convert this video frame to the size of this reference image. That's the scaling term. You have to use a scaling transform and you have to resize the video frame, because this reference image will have a size. So you have to convert this video frame to this size, size of the reference image. Okay, that is called scaling transform. So first apply the scaling transform. Then this reference image has to transform back again to the webcam frame. Okay, so once you convert this video frame to this reference image, then you have to calculate the reference transform, and this reference you have to create a binary mask where you have the object, and you have to replace the object with the video with the virtual environment video. Okay, so finally you will get this. Finally you will have a webcam, and you will detect the object, then you embed the virtual video inside the object which was detected. So this is the final output. Okay, you have the video output, you have the reference video, you have the real-time environment, and this small box is the virtual video which is embedded inside this real-time environment. Okay, this is the augmented reality. So the application is limitless. A lot of application is there. You could go for you could search it on Google, and these are the key steps in AR. The video can be, it's a pre-recorded video, or it can be the virtual video can be it's a 3D model video or animated video, or it can be generated. You could generate the video on real time. So there is you could choose any one of the option. And display devices like a TFT device or a monitor, where it will display both the real and the virtual environments. In the case of this fashion monitoring, the display device is a mirror, like a mirror kind of a TFT camera, TFT device, or it's a screen like a TFT screen, or the display device may be a mobile screen. Okay, so it should be capable of displaying both the real time and real as well as the virtual environment. And the camera calibration has to be done. Like the camera has to be calibrated for the distance, and it should be able to scale, like to scale the parameters of the virtual. It has to map the real to the virtual world coordinates. Okay, and finally it has to be the AR has to be capability of tracking the position and the orientation, and it should be able to rescale the transform. And finally, the registration is nothing but the merging of both the real-time environment and the virtual environment. So these are the key steps in augmented reality. So let us go to the Matlab and go to the demo. Like before I explain this code, I'll show you the demo first, so that you could have a better, like you could understand the augmented reality better. Then we can go to the code. I will explain the code on the presentation. Then we can go to Matlab and we can practice. Okay. First, I will connect the camera. So I'm opening Matlab. Okay, CLC. So this test.pmp is the target image. I'm going to recognize my ID card. That's an object. Like I'm going to recognize the ID card. And this 1.mp4 and demo.mp4. I have two videos inside this folder. I'll play you the video over here. So this is the video from MathWorks. Okay, this is the video from MathWorks.
There are a lot more time to solve on a day-to-day basis. Our software is very properly worked. Closer here, most of the night, then we have to solve.
Okay, and this is one more sample video, like this masterclass series, like. Welcome to. Okay. So this is so these are the two videos, and this is the target image. Okay, this is the target image. So I'm going for Matlab now. So I'm going to connect the camera over here. Okay, so yeah, I'm going to check the webcam list first. Webcam list. Okay, and then I'm going to run the program. So run the program. So if you check now, okay, remove this breakpoint and give continue. So this is the object recognized. So if you check, this is my ID card. Okay, now the object is not recognized. So if you check now, the object is recognized, and it is playing like it has, like, you could also like transfer, like you could scale it and rescale, and you could rotate. So the object, the virtual video will also have the capacity like to rotate the transformation. Okay, so this is an example for augmented reality, where like this is a real-time, this is a real-time image, which this video was embedded into the real-time image. Okay, so you could check over here. So in this we have two options, like one is the camera, one is the frame which was captured from the camera, and another is the video which is stored in the current working folder. Another is the target image. These are the three inputs. Okay, this inputs, you could have one object or many objects you could include in a database. So these are the three inputs. One is the video file which is going to be embedded, and another is the target image, and finally like the input camera. So I'm going to change the video now. Demo.mp4. Okay, run the program again. So this is like, so I hope taken the video frame from the previous web classes and I have embedded that video in this card. Okay, so you could rotate the card like it won't detect. Okay, so once the card is rotated, then you could have the video over here. Okay, so now I think you might have some knowledge in. Let us go to the program. I keep a breakpoint here and I quit the program. dbQt to quit the program. First I will explain you the code on the presentation, then we can go to the Matlab and we can go step by step. Okay, so the first step is to initialize the camera and read the target frame, like read the target image as well as the real-time video from the webcam. So this webcam is 4. This number you have to change by putting the webcam list. This object, first you have to initialize the webcam, and the second code line is you have to read the video file. I have used vision.video file reader. There is another option called video reader. You could also use video reader or you could also use vision.video file reader. So I have used vision.video file reader. Okay, demo.mp4 is a file which I'm going to read, and the output data type is unsigned integer 8 format. It's an RGB format. Okay, red, green and blue. This imread of test.bmp is the target image which I'm going to read, and that's a box image. And RGB to gray, just I'm going to convert to grayscale. The target image, that's my ID card. I'm going to read this test.bmp is my ID card image, and I'm going to read this image and I'm going to convert that to a grayscale. So this is step 1. First you read the video which has to be embedded, then read the webcam, then read the target image and convert to grayscale. Okay, it's simple. 4 lines of code. And step 2, this is the process which we have repeated twice. Like we have seen the same example on the feature extraction, we have seen the same example on the object detection. I will repeat you one more time so that you could have you could have a better understanding on the code. The first thing is to get the snapshot is to get the frame from the camera. Here we have initialized only the webcam. Here we are getting the frame from the camera. Snapshot is to get the frame from the camera. RGB to gray will convert this frame to a grayscale. So we are converting both the target to grayscale and RGB to grayscale because the serve features, direct serve features will work only for the grayscale image, not for the color image. So first convert to grayscale image, because the feature what we are going to be extract is blobs and blobs and the like we are going to blob and the regions. Okay, these are the 2 features which we are going to extract. So these, when you convert to grayscale, there will not be any loss of information. So the information will be there. So there is nothing like when you convert to grayscale, there is no loss of information because the blob feature is not going to change. It's not going to be changed. So convert that to grayscale. Direct serve features is a command which will give you the serve feature points. Okay, you have to apply this direct serve features for the box, the target image and the scene image. The scene image is the one which is from the camera. Okay, you have to direct serve features for the box points and the scene points, and then extract features from the both thing, like extract the features from the box image and the box points and the scene image and the scene points. Okay, so thus this will give you the features of the image, box features and the box points, and the scene features and the scene points. First you direct the features for the both image, extract the features for the both the thing, then match the features for the both the thing, because the scene image contains the image from the webcam. Okay, and the target image is the ID card. I want to find out where the ID card is on the camera on the camera frame. For that you have to use match features. Match the features from the sample and from the sample image what you have, from the input image what you got. So that's the scene feature is the input image from the camera, and box feature is the sample image which you have. You match the features, you will get the pairs, the location of the pixels where you have, and this box points and the scene points will give you the matched box points and the matched scene points. Okay, so if length is greater than 5, then you have a lot of matches over these 2 features. So then you could say then the object is detected, else the object is not detected. We have 2 cases. One is object is directed and object is not directed. If object is directed, then we are going to follow steps 3 to 8. If object is not directed, then we are straight away go for step 9, and we are coming to the loop to the step 2. So step 2 to step 9 is a iterative process, like it is a while loop which should get which has to be repeated for each and every frame. Okay, which has to be repeated for each and every frame. So I will repeat the same code again. Get the snapshot from the camera, convert to grayscale, direct the serve features of the camera as well as the target image. Extract the features from the target box, extract the features for both the thing, for the camera as well as the target. Okay, you will get the box features as well as the scene features. You have to match the features from the box, because you are going to find out the object, the same object from that scene. Okay, so you will get the pair. Box pair is nothing but you will get the pixel locations where you got the matched points. So you take the length of the matched points. If you have more than greater than 5 matched points are there, then the object is recognized, else object is not recognized. If object is recognized, you have to go to this code. First, estimate the geometric transform of the matched box points, the matched scene points, and you create a reference transform. The reference transform is here, this one. Okay, now you have to create a reference transform. This is the target image. So, and this is a webcam frame, and the scale, two transform is there. One is the scaling transform and another is a reference transform. The scaling transform is nothing but resize. Okay, this line, take the video, find the size of the video and size of the image, box image. That's the target image. That's my ID card. Okay, I'm explaining this part now. Take the video. This is my ID card. Find out the size of my ID card. Find out the size of the video frame. Convert this video frame to the size of my ID card. Okay, that is a point here. Size of the video frame, size of the box image, and size size of the video frame and size of the box image. I have to resize. Resize is the command which is used to resize the video frame to the size of the box, to the size of the ID card. Okay. Okay, this is scaling transformation, size of the ID card, and then to estimate the geometric transform is to create a reference transform where you will have the matched box points, the matched scene points. Create the reference transform here, and find scale transform, and this ref dims and rep dims are nothing but these are the size of the video frame and the size of the size of the video frame and the size of the ID card, like the target image. Okay, so the find scale transform is a one to scale, like to rotate the, you have to rotate the video. For example, the ID card is rotated to it has been rotated to another, like if it is rotated to 90 degree or 45 degree, or it may be in movement. In that case, you have to find out the scale transform to rotate the video frame. To rotate the video frame, you need an angle, right? So that you have to find the scale. You have to find the scale transform for the input or for the ID card as well as the video frame. The video frame which is going to be embedded, the virtual video. Okay. Now transform the video frame. Once you find out the scale transform and the reference transform is there and scale transform is here. Now you have to transform this to this video frame. This is the video frame transform. Finally, you have to transform this video. You have to blend this video. You have to blend the video on the original scene. The scene image is nothing but this is the scene image which you get the snapshot from the camera. Okay, this is the scene image. One is the one which you get the snapshot from the camera, and you have to embed this transformed video frame. The video frame is initially it will be the very size. It has been resized to the size of the ID card, and it also has been scaled, like it has been rotated as like the position of the ID card, and it has to blend. Like blending is nothing but joining the operations. You will create a binary mask and you will join the operations, and you will get the final output frame. Okay, this is the output frame which you are going to display. Now This is the same thing to to compute the box polygon and to draw a line. That's all. Like the process is completed. Augmented reality process is completed at this place itself. Like the output frame will have the video, will have the frame which has the embed video, embed virtual video as well as the original frame. Okay, this is to just to draw a line of the box, draw a polygon. First, for that you have to evaluate the box polygon based on the size of the ID card. Box image is nothing but the size of the ID card. First evaluate the box polygon, transform the, again now you have to, based on the reference transform, you have to estimate the polygon, new polygon, like size, the coordinates, new polygon coordinates. Then you have to insert text, is just to insert a text. I am going to just display object recognized on the output frame. Insert text is like you have to just take the current frame and you have to put the current frame, like you have to insert the current frame on this position. Position is 321 to 430 and the color will be the yellow color, and just this is the title of the image, and line will draw the box polygon image. That's all. The same code copy and put it on the else loop and put not recognized, object is not recognized. If object is not recognized, you just put object not recognized and insert a text. There will not be any line command because there is no object here. So line command is used to plot the polygon, box polygon on the object. So here you will not have the line command over here. Okay. So this is the else. Okay, and that's the end of the code. So let us go to the Matlab and we can practice the same code. Okay, I'll show you the output step by step. I'm going to open Matlab. So I'm going to type edit to create a new file. Okay, and I'm going to save this as example1. First I'm going to, this is a lengthy code now, so I'm not going to type. I'm going to show you the step by step output for each and everything. I'm going to copy the code and I'm going to use it, because if I type this code, then it will take a lot of time. We'll be running out of time. First I'm going to take this 3 lines, okay, and I'm going to paste it here. Before this, make clear and CLC. I'm going to ensure my font size, like go for view, publish, go for editor, and let me check the font size, preferences, go for font. Okay, I'll make this as 23. This is 23. Okay. So ex1 is the code. So I have read a webcam object here, like this is 4. This number I'm choosing 4 by seeing the webcam list. Type webcam list here. Webcam list. Type webcam list here. This is 4. I have 4 cameras in my PC. Like I have put 4 here. And vision dot, this is the demo video file reader. Like I'm going to read this video file and I'm going to read the test.bmp. So if you want to see this figure, you put figure of imshow of box image. Okay, so this is to keep a breakpoint. I'm going to stop each and every code. So to stop just to debug. Okay, that's all. If I run the button, so it's showing some error over here. Okay, run the button. Like this is my target. Okay, this is my target image. So first I have read the webcam, I have read the video. So if you check video, disp of video, it has a file name, RGB format, and the file name is here. demo.mp4. Okay. Now I'm going for the next line of code. I'm going to copy this line and I'm going to paste. Okay, I'm going to paste it here. So we are getting a frame from the camera. I'm going to show you each and every it should be, this should be in while loop, while of 1. Okay, this should be in while loop. So before this else I have put, and this as end, this is end. I'm closing the while loop. Let me show you that each and every output. Like I'm going to show you this figure in show of scene image 1, the frame. Okay, just for showing you the matched features. Okay, this code has been already we have repeated on the feature extraction as object addition. I1 and I2 is scene image. Scene image 1, and this is box image, matched box points. This is matched box points and this is matched scene points. Okay, matched box points and this is matched scene points. So I'm going to keep a breakpoint here, save the program. So I'm going to initialize the camera and I'm going to run the program. Okay, so if you check here, like figure, so it's showing the matched figures. So what I'm going to do is I'm going to, this is montage. I'm going to create this as montage, save the program, run the program. Okay, this is the scene image. Okay, this is the scene image and these are all the points which has been matched. Okay, okay, this is the scene image, this is the target image, this is the scene image, and this is the points which has been matched. I'm going to comment this line, this just to show this output. I have used this one. I'm going to copy the next lines of code here. Estimate the transform. Okay, copy this code. You come to length of 5 only when the object is generated. Only when the object is generated, we are going inside this object and we are estimating the transform. Step the frame, resize the frame, video frame rescaled. Okay, step 3, and this is step 4. So scale transform. Okay, step 4 is scale transform, and step 5. So I'll show you the output. Step by step. Video framed out, video transform, video. This is a video frame transform. Okay. Step 5 and now step 6. This is the Blender video. Okay. So I'll show you this figure of output frame. Okay, this output, I'll copy this one. I'll show you the mask, and I'll show you the video frame transformed. This is a video frame transformed. The resized video frame scaled. This is a resized frame. Okay, video frame scaled. This is demo.mp4. okay, so I'm going to run the code again. So now I'm going to keep this car over here to get a match on the program. Okay, if length is greater than 5, so it has been matched. So I keep a breakpoint here and hit the run button to show you the video frame scaled. This is the scaled video. Okay, see, actually what happens is, this is the ID card. I have changed the input video to the size of the ID card. Okay, that is a video frame scale transform. To that I have used the command resized. And after scaling transform, like if you check the video frame transformed, okay, so this is the input frame, and this is the video frame scale transform. Without only the video has been scaled now. Now the background, like the real-time video, is not embedded. It is not blended. Okay, but it has been transformed. The input, actually, first this is the first step. Resize this one. Second step is this. Okay, second step is this, and third step is blending. If you check now, keep a breakpoint here. Okay, this is the mask, this is the blending video, this is the blending video, and this is the mask. Okay, this is the mask. So just I'm going to include the final step 7. Okay, box polygon. Copying this box polygon just to draw. Okay, paste this code. Estimate the points over here, and finally to draw the line. Like this is just to plot and to give a text, like object augmented reality using Matlab and object director, object recognized, and to plot the command. Okay, else if the object is not recognized, you copy the else code here. Object is not recognized, copy the else code. This code already, like we have practiced on the real-time object detection. We use the same code. We are using the same code over here. The only thing is scaling and transform and blending. Only these three parts, the three code has been newly added to this code. So first thorough with object detection and recognition. So now I'm going to run the video. I'm going to clear all the breakpoints and I'm going to run the video. I have a lot of figures. So let me stop this one. I am going to disable all the figures which we have introduced for to verify the output. Okay, to show the output. I'm going to, otherwise it will open a lot of frames. I'm going to disable all the figure command which was used to check the output, and I'm going to display only the final one. Okay, so I'm sure current frame is only the final one. So I have okay, save the program, run the program. So if you check now, clear all the breakpoints, clear all the breakpoints and run the program. So, okay, still there is a figure. Let me check. Okay, this mask, we can forget to comment this mask. Okay. Okay. Quick debugging, clear all the breakpoints, save the program, run the program. So this is the video now. Like if you check this one, there is no tracking in this video. There is no tracking part part included in this video. Okay. So if you change this one, it won't recognize, like only because the features will vary. Okay, there is no tracking part. I'll close this program. I'll run the code which is having the tracking part. The tracking part is quite it's quite complex. You go for final code. I'm running the code with the tracking part now. Okay. So this is the object recognized object. So I will explain the code one more time, and let us go through the code one by one. I'll attach the code on land.pantech.solutions.net. You could download over there and you could try debugging. Okay. So first, initialize the webcam. Then read the video file, video.video file reader. We have read the video file reader over here. ImRead is the command. This is to read the read the target image. I'm test.bmp is the ID card. Convert this to grayscale, the target image to the grayscale, and read the frame. This is a while loop. Okay, while loop which will read the frame continuously. Snapshot is used to get the frame from the camera. Convert that to grayscale. Direct the serve features for the scene image as well as the ID card, the one from the camera and the ID card. Extract both the features and match the features. Finally, you will get the points. If the matched point is greater than 5, then the object is directed. Else, the object is not directed. If object is directed, first estimate the geometric transform. Geometric transform will give you the reference transform, like whether the card is straight or rotated. It will give you the scale. Okay, it will give you the scale. Then now you read the video which was loaded, like the marketing video or the embedded video, the virtual video. You read the video, get the first frame, find the size of the frame. Ref dims will give you the size of the video frame, and ref dims will give you the size of the box image. Now, size is nothing but it gives you the rows and columns in the planes. How many rows and how many columns are there? You resize. Resize is a command which is used to resize the rows and columns. Okay, rows and columns. Find the scale transform. You have to rotate the video to the ID card. Like for that we will be using imwarp. So that will give you the transformed video. Finally, once you get the transform video, then you have this transform video has to be blended with the input camera frame. For that, you use vision.alpha blender. It's nothing but just blending it will blend both the input video as well as it will see the input is scene image and the transformed video frame and the mask, and finally it will give you the output frame. Okay, so with this the augmented reality is completed, and this is just used to plot the line as well as give the text like object recognized. For that, you initialize a box polygon. the polygon size should be the box image, that ID card image, and transform these points to get the new box polygon. Because the one which you have is it may be straight. Like when you give test.bmp, it will be straight, but the actual may vary. If you go and check in test.bmp, the test.bmp is it is straight, okay, but actual may be rotated or tilted like that. So for that you have to give transform points forward to get the actual box polygon. And you, like, this is the position of the text and this is the color of the text. Object recognize insert text is used to insert the text on the current frame, and finally this RGB will be displayed. I am show of current frame will be displayed. Okay, this should be RGB. Okay, finally you get the augmented reality using Matlab. And this object, if object is not recognized, then insert the text. The object is not recognized, then augment and just display the image. Okay, so that's all about augmented reality. With this, I'll close the session.
So the printed certificate is available for 750 rupees. So you will get the internship certificate, like internship printed certificate, as well as you will get the recorded video access for 90 days, and you could download the presentation, you could download the source codes, you could ask for Q&A sessions and participate in forums. So you will have nearly 10 plus projects. So if you want to avail, like, you could avail. The offer price is 750 rupees. And with this, I close the session. I will take the Q&A session tomorrow. Thank you for your time and thanks for coming. Meet you in the next session.